Hello everybody, welcome. Okay, so in our previous classes, we saw the basics of dynamics, about rectilinear motion. We saw what are the equations of kinematics and how to solve a few problems on rectilinear translations using the equations of kinematics. That is, we saw how to find the velocity, acceleration and displacement in kinematics, that is without considering the forces causing the motion, without considering the inertia forces. The next part was about kinetics. So we saw what is the equation of kinetics. It is nothing but Newton's second law of motion, and the extension of Newton's second law of motion is D'Alembert's principle. And by using D'Alembert's principles, we have the application problems of motion on horizontal and inclined surfaces and motion of connected bodies. So we saw motion on horizontal surfaces. So today we are going to see this part, that is the motion on inclined surfaces and connected bodies. Okay, we will go on to the problems. Problems on motion of inclined surfaces. What horizontal force is needed to give the 50 kilogram block shown in figure? So we have a figure. So this is our diagram. The weight of the block. So the weight of this block is 50 kilogram. So this weight of the block is 50 kg with an acceleration of 3 meter per second square up the 20-degree plane. So this plane is inclined plane. See, this is our plane. So this plane is an inclined plane, and this is inclined to an angle of 20 degrees with the horizontal. Now, with an acceleration of 3 meter per second square up, so the movement of the block is upwards. Movement of the block is upwards. That means you are giving a push. We are giving a push on the block. So this is moved up with an acceleration of 3 meter per second square. So the acceleration is 3 meter per second square. This is moved with an acceleration of 3 meter per second square. Assume coefficient of friction between the block and the plane is 0.25. So this is the block. So between this block and between this plane, the coefficient of friction is given as 0.25. Mu is equal to 0.25. We need to find what horizontal force. We need to find what is this P. How much P is required? How much force is required to move this body, to move this object up with an acceleration of 3 meter per second square. So now we will draw the free body diagram. Our first step is drawing the free body diagram. Then we will resolve the forces. Okay. So now we will draw the free body diagram of this block. So we have only one body. We will draw the free body diagram of this object, this body. So while drawing the free body diagram, first is the self weight. So self weight is 50 kilograms. So this is the self weight. So self weight is 50 kilogram. That is 50 into 9.81. We have 490.5 Newton. Now we have a normal force. We have a normal force acting perpendicular to the plane. So this is the normal force acting perpendicular to the plane. Normal force acting perpendicular to the plane. We take it as N. So there will be a frictional force acting perpendicular to the normal force. And the frictional force is equal to mu into normal force. So mu is 0.25, normal force is N. So frictional force is equal to 0.25 into N. So normal force and frictional force at this surface. Now we have an external force P. So this force lies at an angle of 20 degree to the plane. See, because this is parallel to the plane and this is horizontal, this makes an angle of 20 degree with the plane. See, the same angle, see, same as this angle. So this P makes an angle of 20 with the plane. 20 with the plane. So now we can resolve it into horizontally and vertically. We can resolve it into horizontally and vertically with respect to an axis parallel to the plane and perpendicular to the plane. So it is P cos 20 and P sin 20. So this is the axis parallel to the plane and this is the component perpendicular to the plane. So P cos 20 and P sin 20. Now we have to resolve this force, this load, this self weight. We have to resolve this into the axis parallel to the plane and perpendicular to the plane. Okay. So when we are resolving this, see, this is the self weight and this self weight makes an angle of 70 degree to the plane, 70 degree to the plane. So you can extend this line, So this is 90 degree, this is 90 degree. So automatically we get this as 70 degree. That is, this self weight makes an angle of 70 degree with the axis of the plane, with an axis parallel to the plane. So when we are resolving this component, we get it as W cos 70 to the axis parallel to the plane and W sin 70 to the axis perpendicular to the plane. So it is 490.5 cos 70. So 490.5 cos 70 is nothing but 490.5 sin 20. And to the axis perpendicular to the plane is 490.5 sin 70 or 490.5 cos 20. Both are same. So along the plane it is cos theta and perpendicular to the plane it is sin theta. So you find the angle parallel to the plane. So this load makes an angle of 70 degree to the axis parallel to the plane. So we are resolving it into two components. With the axis parallel to the plane it is 490.5 cos 70. Then axis perpendicular to the plane it is 490.5 sin 70. Now we can apply the Newton's law. So we will take sigma Fy is equal to 0 and sigma Fx is equal to 0. Sigma Fy is equal to 0 is the axis perpendicular to the plane. So we get N, upward forces is equal to downward forces. We get N is equal to 497 sin 70 plus P sin 20. And by resolving the forces parallel to the plane, it is the summation of all the forces is equal to inertia force MA. So we get P cos 20, this is P cos 20, this is in the opposite direction, leftward direction, 490.5 cos 70. Now this force F is equal to 0.25 Newton. So minus leftward direction minus 0.25 N minus MA is equal to 0. When you take this MA to the right, you get plus MA is equal to 0. So by solving these two equations, you get P, the force required to move the body with an acceleration of 3 meter per second square is 506.9035 Newton. A mass of 1 kilogram is pulled up a smooth plane by 6 Newton force acting at an angle of 10 degree to the plane surface. If the mass is not losing in contact with the plane, determine normal reaction offered by plane on mass and acceleration of the mass along the plane. So simple problem like the previous problem. You draw the given conditions, draw the free body diagram for the given condition, mark the normal forces, the self weight, resolve it into components, use Newton's second law of motion, D'Alembert's principle, that is nothing but D'Alembert's principle. Solve the equations, we get the normal reaction n is equal to 7.4336 Newton and acceleration is equal to 1.0038 meter per second square. Now next problem, a body of mass 15 kg is initially at rest. Initially at rest means your u will be equal to 0. Rest on a 10-degree inclined plane. So your plane is inclined to 10 degree. So this will be 10 degree. Then it slides down. So there is a body and this body is initially at rest. Then it is sliding down. So movement of the body is in this direction, downward direction. Calculate the distance moved by the body on the inclined plane when the velocity reaches to 6 meter per second. So final velocity is 6 meter per second. We are asked to find this S. The coefficient of friction between the body and the plane is 0.1. So mu is given. Now our aim is to draw the free body diagram. Resolve the forces. Solve the equations. So the only unknown will be, we will get two equations. The unknown is the normal force and the acceleration. So resolve the forces, we will get acceleration A equal to 0.737 meter per second square. Then using the equation of motion v square is equal to u square plus 2as. U will be equal to 0, v final velocity is 6 meter per second. So we have already got A is equal to 0.737 meter per second square. We get S is equal to 24.42 meter. So problems on inclined surfaces is over. Now we will go on to problems on connected bodies when there is more than one body. This is very simple, like we have studied in our friction problems and free body diagrams. When there are two bodies, you have to draw two free body diagrams. When there are three bodies, you have to draw three free body diagrams. Now the problem is, two blocks weighing 300 Newton and 450 Newton are connected by a rope as shown in figure. With what acceleration the heavier block comes down and what is the tension of the rope? Pulley is frictionless and weightless. So this is the heavier weight block and this block is of lower weight. So this block is coming down. So this is your condition. You need to find the tension in this rope. Now we will draw the free body diagram of 450 Newton first and then we will draw the free body diagram of 300 Newton. So there is no horizontal forces, only vertical force. So we are drawing the free body diagram of 450 Newton block. So this 450 Newton acts downwards. This is the self weight, so acting downwards. Now since this is acting downwards, the force in this rope will be a tensile force from the block. So this is T is the tensile force. Now since the 450 Newton block is moving downwards, it is brought down our inertia force will act in the upward direction. That is, this mass into acceleration will act in the upward direction. Now this is the free body diagram of 450 Newton block. Now the free body diagram for 300 Newton block. 300 Newton block, the self weight act downwards. There will be a tension in the block, tension in the rope from the block. So this is the tensile force. Now, so this is the same rope. See, from this to this, it is the same rope. So the tension is taken as T in both free body diagrams. Now, this block is moving upwards. 450 Newton block is moving downwards. 300 Newton block is moving upwards. So when we draw the free body diagram of 300 Newton block, the inertia force acts downwards. So mass into acceleration acts downwards. Now we will write the equilibrium conditions. So resolving the forces, we have only vertical forces, no horizontal forces. So for 300 Newton block, T is equal to minus 300 plus 300 plus MA. All upward forces is equal to downward forces. Same way for 450 Newton block also. So by solving these two equations, we get acceleration is equal to 1.962 meter per second square and tension T is equal to 360 Newton. Next problem. Two weights 800 Newton and 200 Newton are connected by a thread and they move along a rough horizontal plane under the action of force P of 400 Newton applied to 800 Newton block as shown in figure. Find the acceleration of the weights and tension in the thread. Coefficient of friction is 0.3. So coefficient of friction mu is equal to 0.3. So draw the free body diagram of this 200 Newton block and 800 Newton block. So when you are drawing the free body diagram of 200 Newton block, you will have tension in this direction, T in this direction. Then this 200 Newton load act downwards. There will be a normal force acting upwards. So the movement of the block is in rightward direction. So your frictional force will act in this direction, leftward direction. Now there will be an inertia force in the leftward direction since movement is towards the right. While you are drawing the free body diagram for 800 Newton, the self weight acts downwards. We have a 400 Newton acting towards the right. This, I will take another color, okay. This 400 Newton acting towards the right. Now there will be a tensile force acting leftwards in this rope. Now since there will be a normal force acting in upward direction, there will be a frictional force acting in towards the left. There will be an inertia force acting towards the left. So draw the free body diagram, equate the equations, write the equilibrium conditions. We solve the equations, we will get acceleration is equal to 0.981 meter per second square and the tension T is equal to 80 Newton. See, tension is in the thread. This is T, this is tension. See, for 200 Newton this is tension, for 800 Newton this is tension. Next, two blocks of mass 10 kg and 5 kg are connected as shown in figure. Assume coefficient of friction is 0.25. Find the acceleration and the tension in the string if pulley is weightless and frictionless. Now, this is your 10 kg and this is our 5 kilograms. Now, we have two bodies, so two free body diagrams. For 10 kilograms, you will have a self weight. We will have a normal force. We will have a frictional force. Moment is towards the right, so frictional force towards the left, and an inertia force towards the left. And also you will have a tension in the thread. So same rope, so you will have tension for the both free body diagrams. When you are taking free body diagram of 5 kilograms, you will have a self weight. There is no normal force because there is no surface. It is freely suspended. There is no surface. So there is no normal force. So gradually there is no frictional force. But there will be tension in the rope in the upward direction. So the movement is downwards. So you will have a inertia force in the upward direction. So that's all. Draw the free body diagrams. Equate. Use Newton's second law. We will get acceleration is equal to 1.635 meter per second square. And the tension in the rope is 40.875 Newton. Next problem. A block of 1200 Newton rests on a rough inclined plane at 12 degree. So this, you have two planes. This is one plane and this is another plane. So one is inclined plane and another is vertical plane. So this inclined plane is inclined at 12 degree. We have two blocks, 1200 Newton and 800 Newton. We have the same rope. So tension in the rope is Tt. Here it is T. Here it is T. Tension in this rope is T. And the tension in this rope is also T. Now here for 1200 Newton you will have a normal force perpendicular to the plane and a frictional force in the opposite direction. We will have inertia force in the opposite direction. Then self weight. Draw the free body diagram. Resolve the components with respect to the plane, with respect to the surface parallel to the plane and perpendicular to the plane. Now for the 800 Newton, there is no surface. So there is no normal force or frictional force. We have only the self weight, tension in the rope and the inertia force. So draw the free body diagrams. Solve. We will get A is equal to 1.548 meter per second square acceleration and a tension in the rope is 673.7 Newton. And substituting u equal to 0, we get at t is equal to 3 seconds. At t is equal to 3 seconds, we get s is equal to 6.969 meter. Next problem. See, I am not reading the problem, just I will explain it to you. We have two blocks, B and A. So we will draw the free body diagram of these two blocks. For block B, you have a self weight. We will have a normal force. The movement is towards the right. So we will have a frictional force. We will have a inertia force. Then we will have a tension in this rope, T. Same way, while drawing the free body diagram for A. So the only things you have to resolve is this T. You have to resolve this T into horizontal and vertical components. Now when you are considering this block A, you will have a self weight. We will have a normal force. We will have a frictional force and we will have a inertia force. Also we have this 70 Newton external load, external pull and this tension in the rope. So these are the forces we will have for block A. So 1, 2, 3, 4, 5, 6 forces. So we will draw separate free body diagrams for block A, block B. And the coefficient of friction is also different. For block A, between block A and the surface, the coefficient of friction is 0.25, and between block B and the surface, the coefficient of friction is 0.5. So we will resolve and we will get the answers. So next problem, see, you can see there is two pulleys. There is two pulley. This is one pulley and this is another pulley. So tension in the pulleys, the wires connecting the pulleys T, T and T. Now here the tension is 2T. So why we have our aim is drawing the free body diagrams for block A and B. For block A, see, here we don't have horizontal forces, only vertical forces. So block A, we have a self weight, we have a force in the pulley 2T. This acceleration is in the downward direction. Acceleration is in the downward direction. So we have the inertia force in the upward direction. So that's all. Same way for block B, we have self weight, tension in the rope is T, movement is in the upward direction, that is 2A, acceleration is 2A, the upward direction, we have inertial force in the downward direction. So remember, for block A, our acceleration is A, for block B, acceleration is 2A. So remember while substituting these values. Draw the free body diagrams. There is no need of drawing the free body diagrams for pulleys. Draw free body diagrams for A and B. So remaining things you leave. So resolve, we will get acceleration for A, that is A. A is acceleration for A and 2A is acceleration for B. So we get acceleration for A as 1.4014 and acceleration for the block B is 2A. Now tension in the block will be 630.64 Newton. Last problem. See, I have taken this because there are three bodies. Simple problem. Draw the free body diagrams for A, B and C. So you will have three free body diagrams. Since there are two ropes. See, one rope is connecting A and B and another rope is connecting B and this 20 kilogram blocks. So we have two ropes. So T1 is the tension in the rope 1 and T2 is the tension in rope connecting B and 20 kilograms. So draw the free body diagrams for A, B and 20 kilograms. So three free body diagrams, resolve, solve, you will get A, that is acceleration. Acceleration is same for every cases. So acceleration is 4.624 meter per second square. Tension in the first rope is 32.933 Newton and the tension in the second rope is 103.705 Newton. So T1 is 32.933 Newton and T2 is 103.705 Newton. So hope you can solve these problems. So try solving. If you have any doubts, you can ask me. Thank you. Thank you.